Hello friends, I welcome you in my YouTube channel. I am Dr. Sirajul Faisi. Today in this video, I am going to talk about some basic informations regarding particle of chemistry. Important skills required in chemistry particle. Particle is meant to assist the learner to learn and develop the following skills: manipulative skills, observation skills, reading skills, recording skills, computing skills, interpreting skills. Now, friends, what is meaning of manipulating skills? It involves the correct and skillful handling of the apparatus by experimenter. Observation skill involve the use of sense, hearing, sight, touch, and smell to detect changes. Reading skill refer to the ability to comprehend written or printed information. Recording skill entails writing down, for example, measurements or statements of facts or other details for reference. Computation skill involve the use and application of mathematical knowledge on the data collected. And friend, interpretation skill involve studying the data collected and drawing conclusions based on the established chemistry principle. Areas to consider when preparing for chemistry. Chemical symbol must be written correctly. When the chemical symbol is just one letter, it must be in capital. If two letters are used, the first must be a capital and second one be a small letter. They must be separate, not joined. The small letter must not be bigger than the capital one, must not be shaded. In the chemical formulae, any letters that represent one atom of an element must be capital, like sodium carbonate and not the sodium carbonate. You see, oxygen here is creating pollen. It is denoted in the red. A chemical equation must contain correct symbols and formulae, balance and state symbols to show the state of matter of each of the substances involved. Now, writing observation must be based on the following. When there is color change, both original and final color must be stated. Colors and smells of gases should be stated. Colors of precipitates should be stated. Color changes for both blue and red litmus paper must be stated when used. Colors of solution must be stated. A procedure must be correct to the letter. For example, soluble salt must be prepared by adding excess metal to an acid, metal oxide to an acid, or metal carbonate to an acid. In separating a soluble solid from an insoluble one, start by adding a convenient solvent to the mixture. Do not say dissolve the mixture. Insoluble salt are prepared by precipitation, mixing to solution. Indicate what happened at each step. When naming or identifying substances, do it as follows. When the questions leads, identify either the name or formula is allowed. But when the questions lead name, then just give the exact name. Names of ions are not allowed, only correct formula are accepted. If you give both the name and formula, both must be correct. When plotting graphs, ensure they have the following: label, axis, appropriate scale, plotted points must be visible, all points in the table must be plotted correctly, a convenient scale must make the graph occupy at least 3 by 4 page, a straight line must be drawn with a ruler, smooth curves must be drawn freehand. Drawing diagrams must be correctly drawn, operators should be proportional, labeling must be workable, that is, no leakage of the gas. Condition under which the reactions were carried out must be stated. Catalyst, a specific temperature or range of temperature, a specific pressure, a specific concentration. Abbreviations are not accepted. Example, PPT instead of precipitate. Filling the burette. First rinse with about 5 cubic centimeter of the solution with which it is to be filled. Discard the portion of solution used to rinse it. Fill the burette with the solution to the mark. The level of the bottom of the meniscus is then adjusted to be at the same level with the 0 mark. This is taken as the initial reading. Any convenient mark may be chosen at the initial reading for any other subsequent filling. Writing ions in word and wrong oxidation state is not acceptable. Ions should be written in their symbols and correct oxidation state. Example, zinc 2 plus and not zinc plus 2. When mixing two solutions, it is wrong to write no reactions, no change, no chemical change reaction, clear solution form. Correct observation should be a white precipitate formed, a colored precipitate is formed, no white precipitate is formed. There is no white nor whitish solution. A solution is colorless if no color is seen in the solution. Do not add IH to colors of precipitate of solution. Copper solution is blue, not bluish. Using volumetric flask when diluting solution. Measure the required volume of solution to be diluted and transfer it to the flask. Add more distilled water until the bottom of the meniscus is at the level of the mark on the neck. Preparing solution from solid substances. Dissolve the solid in a little water in a beaker. Transfer the solution into the volumetric flask. Add more distilled water until the bottom of the meniscus is at the level of the mark on the neck of the volumetric flask. Volumetric analysis. This is especially in chemistry, which deals with the measurements of volumes of solution of reactants, reacting them as you record the reacted volumes and using the information to carry out calculations based on the data collected. Term associated with volumetric analysis. Standard solutions is a solution of known concentration which is used in titrimetry. Analyte. What is analyte? Is the test solution whose concentration is to be determined. Equivalent volume are the volume of both the standard and analyte solution which react completely without any in excess. The end of the reaction is known as the end point or equivalent point. Commonly used end point indicator. For neutralization reactions, phenolphthalein and methyl orange are used. Redox titrations do not require an indicator since they change color when reduced during the reaction. K2MnO4 potassium manganese 7 changes color from purple to colorless. K2Cr2O7, Cr2O4, potassium dichromate 6 changes color from orange to green. So indicator methyl orange, acid red and pink, base yellow, neutral orange. Screen methyl orange, purple, base orange, and color in neutral solution orange. Phenolphthalein, color in acid colorless, color in base pink, and color in neutral solutions colorless. Litmus solution, color in acid red, color in base blue, and color in neutral solution purple. The mole. The mole is the chemistry unit of the measurement of the amount of substance. It is measuring unit just like a dozen, a pair, or a gross. A pair of shoes consists of 2 shoes. A dozen shoes consists of 12 shoes. A mole of shoes consists of 6.023 into 10 to the power 23 shoes. In chemistry, a mole of substance is the amount of the substance containing 6.023 into 10 to the power 23 particles. In this case, particle can be atoms, ions, molecules, or electrons. The mole of substance may be represented by the chemical symbol or the chemical formula of the substance referred. In chemistry, Cl represents a mole of chlorine atom, Cl2 represents chlorine molecules, oxygen a mole of oxygen atom, O2 a mole of oxygen molecule, Cu a mole of copper atom, Cu2 plus a mole of copper ions, E a moles of electrons, like that. Molar mass. This refers to the mass of 1 mole of the substances. The unit of measurements for the mass is gram per mole. So, oxygen atom symbol or formula O, molar mass 16, oxygen molecule 32, sodium chloride 58.5, copper 2 oxide 79.5, copper atom 63.5, hydrogen chloride molecules 36.5. Concentration of solutions. This is the amount of solute dissolved to make given volume of solution. The concentration of solution may be expressed in terms of mass per liter of solution, gram per liter, or gram per cubic decimeter, or moles per liter of solutions, mole per liter, or mole per cubic decimeter. The number of moles in 1 liter solution is called molarity, M. A solution containing 1 mole of substance per liter of solution is referred to as a molar solutions. A molar solution therefore contains molar mass of the solute per liter of the solution. So relationship between molarity, number of moles, volume of solutions, RFM, and mass per liter of solution. Molarity is equal to number of moles divided by volumes in liter. Number of moles is equal to molarity into volume of liters in liters. Volume in liter is equal to number of moles divided by molarity. Mass of 1 mole is equal to RFM of the substance in grams. So formula C1V1 and C2V2 for dilutions, or M1V1 M2V2, where C1 is the initial concentration, C2 is the final concentration, V1 is the initial concentration, V2 is the final concentrations, M1 is the initial concentration, M2 is the final concentration. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.